Okay, welcome to the next lecture notes of microcontroller courses, Pic16F877. And the next module is about timer and counter. Okay. And the very important hardware for the timer and counter mode is the crystal. And okay, and the crystal is set up as the figure here. We connect the crystal in the OSC1 and OSC2 pin, and the mode we use is the high speed one, and depend on the speed or the frequency of the crystal, we will choose the appropriate capacitor. Okay, example, if we use the crystal 4 megahertz, we have to use the capacitor is 15 microfarad. Okay, and normally we use 20 megahertz, and then we can use the capacitor are 33 microfarad. Okay, and the very important thing is that I already explained in the previous lecture notes that the speed of the microcontroller, and in our big microcontroller, every four duty cycle, the PIC will do one instruction. Okay, one instruction. So that means our speed will reduce 4 times. So that means if we input 20 megahertz, so actually the speed we input just 5 megahertz. Okay, 5 megahertz, and then the cycle, the duty cycle is about 0.2 microsecond. Okay, so that means every 0.2 microsecond the PIC will do one instruction. Okay, will perform one instruction. So please remember that T is 0.2 microsecond. If we use the crystal is 20 megahertz. The timer of the Pic16A77, we have 3 timer: timer 0 and timer 1, timer 2, and timer 0 is a bit 1. So that means timer 0 just have a bit counter, and timer 1 we have 16 bit, and timer 2 have 8 bit. Normally we don't use timer 2 for timer and counter. We use for another function like the PWM functions. This is more important. And this is the flowchart of the operation of timer 0. And when you download the datasheet of the microcontroller PIC, you will see this flowchart, and this will show the operations. And when the first time you look at this flowchart, is complicated, but I think, but actually it's not complicated. It's very easy. So let me explain. And this one we will concentrate on the timer mode. So first one we will look at this bit TOCS, T0CS. Okay, and this one is to select the mode. If this bit is 1, is the counter mode, and this bit is 0, is the timer mode. So we will use this one. So we will, in the timer mode, we will set this bit is 0. Okay, so this one is here, and at this point we will have 2 directions. Okay, and if we choose the bit BSA here is 1, so that means we will choose these directions. So if BSA is 1, so we don't care about this one. Okay, we don't care. But if you choose BSA is 0, we will care about this one. This one is the bridge scalar. What does it mean, bridge scalar? Bridge scalar is that mean we can multiply by the number. Example, if the timer increase 1, 2, 3, 4. If example, if we set the bridge scalar is 4, what does it mean? That means when the timer increase 1, 2, 3, 4. Okay, the timer the timer will think that it's just 1. Okay, it will be 1. That means it will multiply by 4. 4 times. Okay, so example, if we set bridge scalar is 8, so when the timer count from 1 to A, so it will just, the register will just note 1. Okay, and the next one is the bit TMR0. So this one is the register. So when you choose the BSA1 here, the BSA bit here, the timer will increase in here. So the TMR0 will increase from 1 to 255 because the timer count is a bit. Okay, so when it increase more, example 255, it increase to 56, no, it will go back to 0. And when from 255 to 0, it will enable this bit TOEF. So when the number of the timer from 255 go to 0, this one will be set to 1. So this one is for the interrupt one. For the interrupt. So what is the interrupt? The interrupt is that when you set the timer, example 1 second or 2 seconds for doing something, right? So after 1 second, the program will go to the interrupt function, and then it will execute the interrupt function and then go back to the main program. Okay, so to execute the interrupt function, we have to check this bit. Okay, we have to check this bit. So we can summarize that. If we use timer count for the timer functions, so we will use 3 register, 3 special register. First one is TMR0, INTCON, and option register. And the TMR0, that means this one will contain the number of the timer. Example, when the timer increase, the number will be stored inside here, right? We will store inside. And we will option register, more detail about option register. So in here we can see that we have 8 bit. So if we use the timer register, so bit 7 we don't care, bit 6 we don't care, and bit 5, okay, this is the TOCS. Okay, so this one, if we want to use the timer function, so we set this one is 0. Okay, and the next one is bit 4. Bit 4 is if we use the timer function, so we don't care about this one. And then bit 3, okay, here as I explained, if we choose the BSA1, so we don't care about this one, but if we use the bit 3, we set bit 3 is 0, so we care about this one. And this one is to set the bridge scalar. Here we can set the bridge scalar from 2, 4, 8, 16, 32, 64, and then 256. Why we have so many? This one is for any applications, because we can know that the timer 0 is just 8 bit, so 8 bit, and when entry from 1 to 2 it takes 0.2 second, microsecond. Okay, so if we have 255, all right, so multiply by 2.0, so the time is interrupt, it will be very small, so we can increase the number is 256 times, so the interrupt time will be longer, so we can do more things. Okay, let's have a look at some example. Example 1, we want to generate an interrupt using timer every 30 microseconds with the crystal is 20 megahertz. So as previously we already calculate that if we use the crystal 20 megahertz, this we will have the t will be 0.2 microsecond. Okay, so interrupt every 30 microsecond, that means every 30 microsecond the timer will count to 255, right? So we will have the equation 255 minus x. X is the initial number for the timer, right? So this is the number we have to generate for the first time. This will be equal to 30, right? 30, right? So sorry, multiply 0.2 here. Okay, equal to 30, right? So x will be 255 minus 30 divide 0.2, right? It will equal to 255 minus 150, right? So it will be equal to 50. How much is it? 5, right? It will equal to 100. Oh, okay, 255, right? Minus 150, right? So 501. It will equal to 105, right? 105. So we will generate for the timer count. TMR 0 will be 105. Okay, so that means this is the number we have to generate. And example 2, generate it 5 milliseconds. Okay, so each one equal t equal to 0.2, right? Okay, so we have the 255 minus x, right? Multiply 0.2, 5 milliseconds, that means 5,000, right? Microsecond, right? Okay, so when we use this formula, x will be minus, right? So we cannot do, right? We cannot. So that means we have to add the prescaler here, rescaler here. So the equation will become like this: 255, the full equation like this, x, right? Multiply 0.2 multiply y equal to 5,000. Okay, this one will be prescaler. We have to set. Okay, so x will be 255 minus 5,000. Okay, divide 0.2 multiply y here. Okay, and here example we choose which one, how much is it? example why here we choose 256, okay, the maximum. So that means we will have the some number plus number here, right? And this one is for the timer 0 initial number for the timer 0. So that's the equation that you have to remember. And example 3 and example 4, this is similar, okay. And the next one is the interrupt function, interrupt register, okay. And they have many address. You can define anything here. And here, if we want to use the interrupt function, the first one is we have to set this one is 1 to enable global, and bit 6 is 1 to enable the function, and bit 5 is to enable the timer function, okay, timer function. And we don't care about bit 4 because this one is for counter mode, this one is for interrupt, another interrupt mode. And here, okay, when we program, we have to check this bit. If this bit go to 1, so that means what happened? That means there is a change from the timer TM0 from 255 to 0, okay, from 255 to 0, okay, to 0. If this one is 1, okay, so we have to check this bit for the interrupt, okay. And bit 1 is we don't care about this one. This is for another interrupt, we call it external interrupt. And bit 0 is we don't care about because we use the timer mode, okay. Okay, let's have a look at the example. Example, we want to change the status of pin B0 here every 1 second. We use timer to change the status of bit. That means after 1 second it will be logic 1, and after another 1 second it will become 0, and then 1, and then 0 again. This LED will flash, okay. And okay, so let's have a look at the example code. Here we define 3 register, right, for the timer, okay. And then we set the number here, okay. Let's have a look at why this one is the number. Okay, first we have the option register, right? Option register. Here we set, what is it? 1 1. That means this is 1 1. Okay, any number because we don't care. Then the next one is 0 0. That means we use the restore. Okay, we use the restore for timer. Okay, and then the next one is 1. This one is we don't care, so any number is okay. And this one is 0. Bit 3 is 0. That means we will use the prescaler for timer 0. Okay, because this is 1 second, so we have to use the prescaler. Okay, and then the next one is 111. 111 is we use the maximum is 256. Okay, and the initial position is 60. Okay, 60. Why 60? Because we will have the equation for the calculation. What is the equation? The equation is 255 minus x, okay, and multiply 0.2, okay, multiply x equal to here is 1 second, so this is we have 1000 here. 1000 here is 1000 microsecond, and 1000 microsecond. Okay, and then 1000 microsecond we have the multiply okay, 1000 microsecond first, and then this is y, right? Okay, and this one is 256 here. Okay, and then we calculate x will be about 60. Okay, x is about 60, so we have the initial number for timer count is 60. Okay, and then the next one is the interrupt. So the interrupt is we will use 111. Okay, this is 1, this is 1, and this is 1. Okay, and this is 0. So because we this one is for enable all the function, enable all the interrupt function. Okay, and this one we don't care because this one for external interrupt, another function, don't care. And then this one is TOEF here. Okay, TOEF here. Okay, so every time is we will set this not overflow. Okay, and then 0, here is 0, and this is 0. Okay, and we have this program. Okay, and then here we will set another variable et. It will be 100. So we will have every time we will check this variable 100 times, and then we will generate the toggle function. Okay, and in the compiler, if we don't want to use the register, we just need 3 functions: setup timer, set timer, and get timer. And then setup timer, this is for the prescaler here, and then this one is set the initial number for the timer, and this one is to read the timer value. Okay, read the timer value, and remember that the value timer is 8 bit. Okay, 8 bit. And then we have to enable all the interrupt here. This one is the function for enable the interrupt. And let's have a look at this one. Okay, and this one is similar to the previous one. I will set timer 0, initial number is 60, and I set prescaler is 256. Okay, and then I set the number of the variable t here is 100 times, because this is just 1000, right? 1000 microsecond multiply 100, this will be 1 millisecond. This will be 1 second. Okay, this will be 1 second. And this is the timer module for timer 0.